Assalamualaikum. My name is Nur Alia binti Kamal. Today I'm going to present my final year project, a review on synthesis and characterization of hierarchical zeolite 5 for catalytic cracking gas oil. My supervisor is Cam Dr. Narizawati Ahmad Tajuddin. This is my table of content, which consists of 5 parts. For background study, zeolite zirconium 5 or zeolite 5 has been used in many applications, especially in petroleum refining, such as catalytic cracking. However, according to Spec 2020, catalytic cracking can lead to the formation of the coke, which occur on the surface and in the pore of the catalyst, which results in the deactivation of catalyst. In this literature, zeolite 5 has been reviewed via modification of hierarchical structure via top-down and bottom-up strategy by combination of the illumination and desilication process with soft template using tetrapropyl ammonium bromide and steaming treatment, which adapted from Hierarchical and Characterization 2020. Next is problem statement, where zeolite 5 has tiny pore and it restricts the transportation of larger particle. Besides, it can form coke during catalytic cracking process. For a significant study, according to GIATL 2020, by introducing hierarchical zeolite 5, it is proven that it can facilitate in the transportation of macromolecule and zeolite coke performance is improved. The objective of this review is to review the synthesis of zeolite 5 for catalytic cracking gas oil and to review the modified of zeolite 5 by introducing hierarchy zeolite with mesoporous structure via top-down and bottom-up strategy, and lastly to review the characterization of zeolite 5 by BSRD, FTIR, SEM, ammonia TPD, TGA, ICPOES, BGH and T-plot method. Next is literature review. According to Vedring and Fichet 2020, catalysis can be defined as the addition of a non-consumed material to a chemical reaction to speed up the process. It has two types of catalysts, which are homogeneous and heterogeneous catalysts. Homogeneous catalyst is catalyst that react in the same phase, while heterogeneous catalyst is catalyst that reacts in different phase. Example of heterogeneous catalyst is zeolite 5, and according to KKI ETL 2019, zeolite 5 have good characteristics such as good hydrothermal stability and great surface acidity. However, according to Spec 2020, catalytic cracking gas oil can produce coke because it occurs on the surface and in the pore of the catalyst, which can lead to the deactivation of catalyst. Thus, hierarchical zeolite 5 is introduced to overcome the problem. There were two approaches to synthesis to a hierarchical zeolite 5, which top-down and bottom-up strategy. Top-down strategy consists of the illumination and desilication, while bottom-up strategy consists of hard template, soft templates, and free templates. According to GIA ETL 2019, each approach has its own benefits and drawbacks. The benefits of top-down strategy were high silica-alumina ratio and it was cheap, while the drawbacks were secondary porosity less adjustable and also broad pore size. The benefit for bottom-up strategy were it has variety of morphological structure and can improve the surface area, while the drawbacks were low thermal stability and quite pricey. Next is the reviewed experiment flow charts, which adapted from Hierarchical and Characterization 2020. According to them, 65 of silicon dioxide per 1 of aluminium dioxide proportion has been prepared to develop zeolite 5. The starting material used to prepare hierarchical zeolite 5 in their experiment were sodium aluminate, sodium hydroxide, tetrapropyl ammonium bromide, and acid sulfuric solution. Next, according to them, desilication, dealumination, and soft templating procedures has been utilized in the second stage to induce mesoporosity in the synthesized zeolite 5. And the resulting powder has been calcined at 550 Celsius for 5 hours. The hierarchical zeolite 5 in the experiment has been characterized by SRD, FTIR, SEM, ammonia TPD, TGA, and ICPOES. Meanwhile, the characterization of FCC catalyst, which was hierarchical zeolite 5 for catalytic cracking gas oil, has been carried out in microactivity unit, which was a plug flow reactor for vacuum gas oil. Next is result and discussion. For catalyst composition, according to Taleb-Bianchi-Akalai and Sarigi 2020, the hierarchical sample had a higher silicon dioxide per aluminium dioxide ratio than the parent zeolite 5, which due to the acid leaching by sulfuric acid after base leaching with sodium hydroxide. Next is PSRD, where according to parent ETL 2019, the PSRD patterns of parent zeolite 5 and hierarchical zeolite 5 samples show no extra unexplained peaks, demonstrating that all of the synthesized samples were true MFI type material. For FTIR spectroscopy, Taleb-Bianchi-Akalai and Sarigi 2020 postulated that in their experiment, the distinctive bands corresponded to internal and exterior symmetric and asymmetric stretching, double ring vibration, and TO bending in the FTIR spectra of parent zeolite 5 and hierarchical zeolite 5 sample. For nitrogen absorption and desorption, Krishnan and Sabarish 2020 agreed that the zeolite 5 sample has a type 1 isotope, which is the characteristic isotope for microporous material, while the hierarchical zeolite 5 sample has a type 4 isotope. For ammonia TPD analysis, according to Krishnan and Sabarish 2020, after the base or acid washing and soft templating operation, the strength of medium acidity decreased significantly because of the creation of mesoporosity in the framework. For TGA analysis, Taleb-Bianchi-Akalai and Sarigi 2020 postulated that the zeolite 5 and hierarchical zeolite 5 in TG-DTA curve showed a single modest weight loss, which corresponded to the strong heat thermal of the catalyst. For SEM analysis, in Taleb-Bianchi-Akalai and Sarigi 2020 experiment showed that the hexagonal shape of C zeolite 5 crystal that form bigger agglomerates, but after the experiment it showed the existence of mesoporous structure in the D hierarchical zeolite 5 sample. For effects of hierarchical zeolite 5 on the FCC activity, in Taleb-Bianchi-Akalai and Sarigi 2020 study, the reaction conversion and propelling yield obtained in their study were the highest than those obtained in the previous study, indicating that the synthesized FCC4 catalyst, which made up of hierarchical zeolite 5, had significant activity. In conclusion, in this review, factors impacting zeolite 5 catalytic performance in catalytic cracking gas oil were reviewed from the perspective of zeolite 5 with specific morphology, hierarchical zeolite 5 and acid properties, and there were so many methods to develop hierarchical zeolite 5. Each approach has its own sets of benefits and drawbacks. In fact, it would be preferable to combine the benefits of each method and build a hierarchical zeolite 5 with greater activity. It is also significant to establish a low-cost and effective methods in preparing hierarchical zeolite 5. This is my reference list. That's all from me. Thank you for listening.